Good morning, everyone. If you are watching this video, it's possible you just finished your test today. So great job. Okay, so I have a lot of time, but I do want to start by saying that I don't think that everybody in the class really knows how to study. Some people do. But please make sure that you understand that you will be more successful if you take those success criteria and make a flashcard, make index cards and write each bullet point on a separate index card, or maybe all of one list on an index card. And then you look at the index card, the other side, you have a little hint for yourself, and then you try to remember those success criteria. If you did that, then when I ask you questions with the vocabulary, you would know what I'm talking about. But this week, I said slope-intercept form, and some of you guys looked at me like I was from Mars. All right, so that shows a lack of study. You should always know the vocabulary. And when you start to practice and go through the steps, some of you have found that it's really not that much work. It just seems overwhelming at the beginning. So let's take a look and see where we're going to next. And I'm starting from here because this is what you can always do, could always do, and guess what? I even have algebra and geometry here. So if you need help with those classes, just know you got this resource available as well. And I'll be here at the middle school cheering you on. You can send me a math question if you have them, but ask your teacher first. Okay, so we've done mostly all of this. Did skip a few things, but now we're in systems of equations, and we've done these three. We're not going to do dilate triangles, but now we are going to go to number of solutions. So one more week of systems, really maybe two if we tackle the word problems, skip scientific notation, and move on to data at the end of the year. Okay, so but right now let's talk about number of solutions. Are you ready? Okay. I hope you said yes and not a sarcastic no, because attitude is everything. Okay, so write this system down. If you have that success criteria list in your head, then you should look at this system and say standard form, standard form. That's what you should say. Okay, and so we had a video about graphing in standard form. And now it's time to go back to it. So we have two standard form systems. So I'm going to write SF. Not San Francisco, but standard form. Okay. And so 2x plus 3y equals -6 is our first equation. So actually, I'm going to write it a little bit to the side, and then I'll just be able to scroll down and have my work next to the graph. That'll be helpful for you. Okay, so when we have standard form, we get the intercepts, we plot those and draw the line. Okay, so the x-intercept is one of the intercepts, and the y-intercept is the other intercept. And the way we find the x-intercept is by setting the x term equal to the number on the right side and solving. 2x equals -6. Divide by 2, divide by 2, x equals -3. That means we have a point at -3, 0 on the graph of this line. The y-intercept is 3y equals -6. Divide by 3, divide by 3, y equals -2. That gives us the point 0, -2. Remember, at the x-intercept, the y is 0. At the y-intercept, the x is 0. Solve that. Okay, now let's do the other line in red. So on the other side, I'm gonna write 3x minus 4y equals negative 12. But I am gonna follow that same process for the x-intercept and get negative 4. And I'm gonna follow that same process for the y-intercept. Just setting equal and dividing. And then the two negatives make a positive. And so I have my x-intercept for the red line is going to be negative 4, 0. And my y-intercept is going to be 0, 3. Okay, let's scroll down and we'll put these things on the graph. And then we will be able to see how many solutions. We'll be able to talk about the actual problem. So our blue line, hey, look at that, blue and red, just like I used. That was a blessing there. All right, so negative 3 and then 0, negative 2. So I just graphed the x-intercept and the y-intercept of the blue line on the graph. Negative 3, negative 2. You see that? Now I'm going to graph the red intercepts. Negative 4, 0 is right here. And 0, 3 is right here. Okay, so these lines intersect, right? So that means they have one solution. All right, so this problem is one solution, but I want to show you the other choices. So it's possible that we got something like this. In fact, yesterday at the graphing station, this was the second problem. Parallel lines. Parallel lines would be no solutions. Please write that down. Parallel lines equals no solution. Okay, so that's one thing. And we say intersecting lines. Yeah, intersecting equals one solution. And then the other thing that could have happened is we could have had two different equations that are actually for the same line, and it would look like that. And so when the two equations are the same line, that is, so I'm going to write same line, that is infinite solution. If you remember when we solved equations, we did the same thing. We started off by just talking about how to solve simple equations. And then we got to the point where I had to tell you about equations that had no solutions and infinite solutions. Systems work the same way. What? Oh, I left it there. Okay, there we go. All right, everything is well with the world, and we have a new problem. Okay, so yeah, go for it. Okay, so I've given, if I'm looking, they're both in standard form, gonna graph those intercepts. They're in slope-intercept form, gonna graph it with the y-intercept and the slope. Then you're gonna look and see, do they cross? If they cross, one solution. Are they parallel? They don't cross, no solution. Are they the same line, like they line up, you graph one line and you graph another line and they're the same line? That would be infinite solutions. Moving on, let's say you don't have a graph. How do you know then? Well, it's still the same as it would be on a graph, but I'm going to make a little key over here. So one solution means you get x equals a number and y equals a number. Everything works out, you know. It's a happy thing. No solutions means you get, again, just like we did with just like we did with equations. If we get our variables all cancel out and we end up with like 7 equals 7, a true equality. Right, this is our example. Doesn't have to be 7, but if we get a true equality, then that would not be no solution. That would be infinite solutions. True equality with no variables. And then no solution is a false equality. So like 5 equals 7, this makes it with no variables. All right, so let's go ahead and let's look at this one. So I'm going to show you something that you can do if you have both equations in standard form. You can do this really crazy thing where you add the equations together. But I think it's actually kind of easy. So 6 plus 6 is 12x. Negative y plus y, negative 1 plus 1 cancels out. And negative 1 plus negative 1 is negative 2. So we get an answer for x.
Good morning, Ms. Trayor. Do I interrupt? Ms. Trayor, would you please contact the president?
And then if we get an answer for x, then we're going to get an answer for y. So I'm going to say one solution. Okay. All right, let's do another. Okay, I'm just going to erase my work here, but I'll leave the key up there. Okay, so you write this problem down. Here we go. Ready? Let's try that adding thing again. What was that about, Mr. Field? You never showed us that. Well, now I did. All right. 5x minus y equals negative 2. When you're doing this kind of work, you always want to look and see if you see a pattern. All right, so we're going to add them together again. 5 and 5 is 10. Negative 1 and negative 1 is negative 2. 2 and negative 2 is 0. So now, when I add them together, I get, oh, they don't cancel out. Oh, I have to show you that much. All right. I am not going to go that far because I don't want to do too much in 1 week. So we are just going to do number of solutions graphically. And I want you to have the notes that I've written so far for the algebra. But if we finish this problem, then I'll have to show you a little bit more than I want to show you at this moment because I don't want to do too much at once. Now, of course, you can use the Khan Academy if you're like, no. I want to know. I'm going to figure this out. Go for it. But for everybody that wants to, and for your grade, it's going to be number of solutions to systems of equations graphically for next week. All right. Thanks for bearing with me.